Welcome back, everybody. This is our third and the last lesson on files. In this lesson, we're going to learn about bytes data type, and we're going to learn about the byte order, the endianness, and then we'll learn how to write and read binary files. So let's move on. All right, so before we go into details about reading and writing text files, let's first go over some number formats, okay, that computer uses, okay. So binary, which is the core binary number format, the computer deals with, it's base 2 and has 0 and 1 as digits. Decimal, the regular number format that we use, is base 10, and we have 0 to 9 digits. Octal, basically base 8, has 0 to 7 digits. And finally, hexadecimal, base 16, it has digit from 0 to 9, and then we adopt the first 6 English letters as digits up from 11 to 15. Okay. Sorry, 10 to 15. All right, so at the core, the computer works with binary numbers. CPU only knows how to speak 0 and 1s. So it uses binary format, zeros and ones. So we know that binary is really messy and long because of the low depth of the digits. We need a lot of binary digits to represent some small things. So it becomes long, messy, and error prone. Okay. So in representation, we usually use hexadecimal, which provides the shortest number of system, right? Because we have a higher base. Okay. All right. So if you take decimal to 55, it's in binary. We have 8 ones. So we write it like, 0B. And octal, 0O, it's 377. And in binary, hexadecimal format, it 0xFF. Or we can also use 0/ as well. Okay. All right. So let's talk about storage of size of the memory and storage in particular. Okay. So we measure storage size in computers in bytes. Okay. So we call zeros and one a bit. Okay. So there are 8 bits in 1 byte. Okay. And then there are 32-bit. So there are 4 bytes to 32-bit number. Okay. Or 32 divided by 8, right? So 64-bit number has 8 bytes, okay, of storage. All right, so if we take a 1 byte, so it's 8 bits, so the maximum number of digits it can has basically 8 ones, okay? So that's the maximum binary number it can carry, right? So a single byte can carry. So that value is actually in decimal 255, okay? So in hexadecimal, we write it like it's FF, and we write it like 0xFF or /XFF. Okay. All right, so it's /F XFF. Okay. So we saw that 2 hexadecimal digits. There are 2 hexadecimal digits in 1 byte. Okay. So basically, we need then 4 groups of 2 hexadecimal digits to represent a 32-bit value. Okay. All right, so let's talk about a little bit on memory addresses. Okay. So when storing data, basically computer stores groups of bits of various sizes depending on the data size in memory. Okay? So each such group assign an address in memory. Okay, so we call it a reference or the address. Okay, so each such group assign an address in memory. Okay, so then we use this address to access that respective data. So in most computers, the smallest such group size is 8 bits or 1 byte. Okay, so smallest such group is 8 bits or 1 byte. Okay, so larger groups need more storage, so we basically arrange them sequentially in bytes. Okay, so then we have this problem. Okay, so how do we arrange them, right? In what order do we arrange them? Okay, so and there can be many, right? So for example, we can arrange them from left to right or right to left. All right, so there has to have a convention or standards in here. Otherwise, there's be chaos, right? So, okay. So basically, again, the memory is arranged sequentially. Okay. So, and it's marked with set of addresses. Okay. So we can use basically memory sequentially to store data. And that's the way basically we store data in memory. So it's a sequentially arranged set of bytes. Okay. All right. So then we talk about the standard. In what order do we arrange them? So there are two standards. Okay, there are two ways. We call them byte order. There are two ways to order storage or bytes. Okay, so big endian and little endian byte orders. Those are the two. Okay, all right. So let's first check one at a time. Okay, so in big endian, basically we store decreasing numeric significant values in increasing memory addresses. Okay, so again, we store decreasing numeric significant values, okay, or bytes in increasing memory addresses, and which is known as big endian. So let's take a 32-bit binary number, okay, in memory, okay. So we have the memory sequentially arranged. So address, say 0, address 1, 2, 3. So the addresses are arranged sequentially and increasing order, okay, as we go down. And we're going to store a 32-bit binary number in this memory, okay. And notice that this width is right. So this width is 1 byte, okay. All right, so 8 bits. All right, so let's check sorry 8 bytes. Okay, all right, so let's take a look. Okay, so we have this width is 8 bytes. Okay, and we're gonna store 32 bits, so we need actually 4 bytes of data. Okay, all right, so this width is 1 byte or 8 bits. Okay, so to store 32-bit data, we need 4 bytes. Okay, let's take this number. This is 32-bit integer 3, okay, in binary form. right? So we have, so in binary form 3 is 1 1. So in 32-bit form we have 4 bytes, 1 2 3 4. 4 times 8 is 32. So 32-bit int is shown here. So let's see how in big endian format we how we order these bits, okay, bytes, sorry. All right, so this is the most significant byte, and it goes to the right least significant memory address, basically the starting memory address, okay. So and then next one, next set goes to the next set goes to the next set goes like this, okay. So basically we stored each byte, okay. So basically it started off with the most significant byte, and then we stored it in the first memory address. Then when went to the next level of significance and stored it in the next byte likewise, right? So the memory address increases as we go down, and we stored the lesser significant uh, set of bits, okay, as we go down, okay. So that's big endian format, and we can also take a look of that same number in hexadecimal form as well, okay. So the hexadecimal form, it's 0 0 0 0 0 0 and 0 3, right? And this is the order that we store in big endian format, okay. So again, it's really important to understand what is this about, okay. So store in decreasing numeric significance in increasing memory address. Memory address increases as we go down, okay, and the significance decreases as we go towards left, okay, sorry, right, okay. All right, so the next one is little endian, okay. In little endian byte order, okay, we store increasing numeric significance in increasing memory addresses. So we know we call it little endian. So let's take a look at the same scenario for little endian byte order, okay. So we have the sequentially arranged memory, okay, and our number 32-bit integer, okay. So we store it like this. So we take the least significant, okay, um, right. So one in the first memory address, and we go to the next one and then go down. So basically, as we increase, as we go towards the increasing significance, we store them in increasing memory address as well. Okay, so this is known as little endian memory order. Okay, byte order. Okay, so usually this little endian is the most common CPU byte order these days. Okay, all right, all right. So likewise, we continue. Okay, all right. So now before we go into file read and write, let's talk about first. Let's learn about binary sequence formats. Okay, so there are three types of binary sequences. Okay, so bytes, byte array, and memory view. Okay, I'm only going to go over bytes, so I urge you guys to click this link and read about it a little bit. Okay, all right. So core built-in types, bytes and byte array. They can manipulate binary data. Bytes are immutable. Byte array is basically mutable counterpart of bytes. All right. Memory view basically allows access to these memory objects that support buffer protocol, okay, without copying. Okay, so basically it's enable access to memory of those objects that supports buffer protocol. Okay, and bytes and byte arrays support buffer protocols. That means we can use the memory view object to access memory of bytes and byte array objects. Okay. Okay. All three types support common sequence operation. Okay. So you have to check them out because we did common sequence operation in our week 3. So please check them out. Okay. Okay. All right. So let's learn about bytes object. Okay. So bytes objects are sequences of single bytes and they are immutable. Okay. Remember again, they are sequences of single bytes and they are immutable. Okay. So that means you cannot assign, you can do item assignment. Okay. So we can easily create a byte literal by simply adding the prefix B, which represents binary, into a string literal. Okay. So like this, and we can create this CO byte object. Okay. So it's a byte literal. We call it byte literal. And they are behaving similar to string, in fact. Okay. So in any of the string literal, only ASCII characters are permitted. Okay. And these basically behave like mutable sequences. Bytes. So bytes object behaves like immutable. Sorry, I said immutable. Immutable sequences of integers. And we saw that they are like we use string literals to create them, but inside they are actually immutable sequences of integers. Those values should fall between 0 and 256. Okay, so the values, the sequence values inside must be between 0 inclusive and 256 exclusive. Okay, so that means basically elements are integers. Okay, all right. So if you take B code literal, this byte code byte literal, and first item is return 99. Okay. All right. So since we have 2 hexadecimal digits for 1 byte, okay, we can use hexadecimal numbers to describe binary data. Okay, so simply pick them, 2 of them, to describe binary data. Okay, let's move on. All right, so let's check on these. Okay, so I have my PyCharm pre-formatted. Okay, so I'm going to go over here. It's slide 12. Okay, so this is, we have a byte literal. Okay, so let's print that out. Okay, all right, and let's also print the type of byte. So just to verify, okay, type CO. Okay, all right, and also we can print the first element too. Okay, and just for the fun, let's print ORD value of character C, and we'll see something notable similarity. Okay, all right, so run it. Okay, so we have it. So go back to result, slide 12. So we have, so this is the the byte literal that we printed, and this confirms the class or the type is bytes. Okay, and I printed the first element 99. Okay, and the ORD value of C also 99. So we have C over here, right? So we can see that basically inside these byte sequences, they're actually integers less than between 0 and 256. Okay. All right. So let's go back to our slide. Okay. All right. So we already learned, okay, one way to create a byte literal is, right? We already learned how do we create that. Okay. So, but what are the other ways to create bytes object? So we can pass, so we can use the, basically we can use the constructor, bytes constructor or bytes built-in function. Okay. And we can pass a number which is going to be the length, right? And it's going to return byte objects of zeros of this length. Okay. So for example, right, bytes 5, bytes 5, so 5 is just an integer, right? So when we do pass 5 like this and then run it, we're gonna get byte object of all zeros. See that all, they're all zeros. Okay, all zeros. We can pass an integer iterable to a to byte built-in function too. Okay, so notice it's an integer iterables. Could be a integer list, could be a range, could be yeah. So those things, right? So let's see down in here. We are passing a list of 2 numbers. We get this. Okay. So 1 and 2. Okay. All right. So that's one way of creating bytes object. We can also pass an object to bytes built in as well, but this object must support buffer protocol. Okay. So only when we can do it. Okay. All right. So so we can also convert an integer number into byte object too. Okay. For that, we are provided by the integer class or int built-in function. Sorry, integer class. Sorry, this method called 2bytes. Okay, and we can use this method to create a byte object from integer number as well. Okay. So how about floating point numbers? And we'll see that um, there's no 2-byte method for floating point numbers. We'll have to use this module, struct module, and the pack method we have inside that module. Okay. So please click on this link and I read a little bit more about this valuable module in Python. Okay. All right. So let's check on these real quick. Okay. I'll go back over here. All right, slide number 13. Okay. So this is just passing a number, and we're going to verify that it's going to be just 0 filled byte object. And if we do so like this, now it's a integer iterable or a sequence. Okay. So we're going to get the respective binary object. Okay. And here, basically, there's another way of testing for that. So in this case, it's a integer range. Okay. Here it's an integer list. It's integer range. Let's check on that as well. So I'm gonna get rid of this test. Okay. All right. So let's run this one for now. Okay. All right. So slide number 13. Okay. So we have bytes 5, all zeros, okay, byte object, and bytes 1, 2. So I pass 1 and 2, list of 1 and 2, and we get this. Okay. Same for range. So this range gives me number 1 to 2. Okay. If I pass it, you get the same bytes number, bytes object. Okay. All right. So let's go back to our code again. Okay. All right. Now we can use this. What if we like here? Remember earlier we said, okay, so these numbers has to be less than 256. Let's try that out here. Okay. So I'm going to unblock this and let's run this and see what will happen. Okay. So in this case, we have integers, but they are larger or equal to compared to larger than 256 or equal to, right? So run it. Okay, so you get this error. Okay, so the error is basically a value error. Okay, and then value error. Okay, so okay, so right here. Okay, so I'm gonna block it back again. Okay, all right. So we can also create or convert a string to byte object as well. In this case, we have to basically get the string, okay, and we have to put the encoding type. So what is the encoding? This could be ASCII2 or in my case UTF-8, Unicode text format 8, okay, Unicode standard. Okay, so let's check on that as well. So we have yeah, right here, B Python. Okay, so I pass Python and I get basically the literal, okay, bytes literal. Okay, all right, so let's go back to our lesson now. Hexadecimal values. So let's put the value, let's say decimal value. Let's say this number. We can get a number like 7. Okay, so let's say, all right, so 7. So I'm gonna get it right like this. X7 equals 7. Okay, all right, and then so right here it's 7 as the decimal format. So to get the binary, we use bin method. Okay, bin function, and then we pass 7. Okay, and the next one, so is getting octal version. All right, so it's OCT function. Okay, OCT, and pass the same integer. And lastly, hexadecimal hex function, and we pass 7. So let's print it out and see what we get. Okay, so for 7, okay, so we have the binary number. So for start off with 7, basically a digital decimal version is 7, and then the binary version is 111. So we write 0B111, and octal version is 0O7, and hexadecimal version is 0x7. Okay. All right. So next, let's see. Now, I said we can convert an integer number into a bytes object, but in order to find what is that function, let's try to get the attribute of the list. Sorry, integer object. In this case, I'm going to use dir method. I'm going to pass the integer. So this dir function capable of listing returning a list of all the attributes of a given Python entity. In this case, it's an integer. Okay, so let's run this one. Okay, so you can see that it listed all the attributes available from the integer type. And if you go all the way down to the end, you can see some functions like conjugate, numerator, real, and bit length. And at the end, you see that this is 2 bytes method. So we're going to use that bytes. So there are 2 parameters to this function, but let's just simply apply, like write it like this. Okay, so I'm going to run it. Okay, okay, so this should be 7. Yeah, so put 7 like 7. Okay, all right, so here also, okay, all right, let's run it again. Okay, all right, so it gives me an error, right? So what's the error? 2 bytes missing required argument length. So basically, when we do this conversion, we need to give the bit length of whatever that number we have converted. So in bytes. Okay, so in here, so let's put bytes like 4. Okay, so it's 32 bits, 4 bytes. Okay, and then okay, and then over here we need to provide the byte order. Okay, so let's check on that too. Okay, so I'm going to run it like this. I'm going to get another error. Let's say now 2 bytes missing required argument byte order. So the byte order, let's give the byte order little. Okay, and rerun it again. All right, and I have the 32-bit little Indian format bytes. Okay, so notice the most significant digit is right here. Okay, at the beginning. Okay, all right, so and then there are 4 bytes, 1 2 3 4. Okay, all right, so let's do the same for now big endian. Okay, so I'm going to copy it over here and change it to big. So that's the parameter for big endian, and you run it. Okay, I get the big endian version of 32-bit integer 7, and you can see that, and the least significant bit sorry, this way memory increases, right? So it's in here right now, the 7, digit 7. All right, okay, so let's move on. So the next method we saw over there is basically we can pass an object that is capable of buffer protocols that support buffer protocol. So byte array object supports buffer protocol. So I'm going to create a byte array object. Okay, and I'm going to simply pass this integer iterable into byte array. So this is going to give me an byte array object, and byte array object supports buffer protocol. So I should be able to then verify, okay, so bytes method can take an object like that and then convert it to or make it a bytes object. Okay, so let's write this one. Okay, and then run it again. So we got, right, so we got this. Okay, so the bytes object. Okay, all right, so last method is basically how do we convert a floating point number to a bytes object. For that, we need to use the struct method. Okay, so I already imported it over here. Okay, so struct method, and in there we're gonna use the pack method provided in there, and it takes the 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 mode parameter f, and then floating point number that we have over here, right? So, and let's check on that. Okay, so okay. And there are a whole bunch of options available, not only for floating point numbers, a variety of formats there. Okay, so just read about it, guys. Okay, all right, so let's run this one. So I already applied the bytes constructor or the built-in function, and I pass um, this object. I'm gonna get a I'm going to convert this floating point number into bytes format. Okay, all right, we got it. Okay, over here. All right, so let's go to our lesson. Okay, all right, so let's learn about how to read from a binary file. Okay, so we can consider these binary files as streams of bytes, right? They have zeros and ones, right? So in fact, any files are zeros and ones, right? So the streams, basically, then we need to have the proper, we need to apply the correct byte order in order when we write or read them. Okay, all right. So opening for reading in binary mode is RB. Okay, and then we can use the read method. Okay, n here is number of bytes. Okay, that we're gonna read. Okay, so after we read, okay, so it's the bytes type. Okay, so the read data will come as bytes type, primitive type that we just learned, and that's the reason that we learn it. Okay, so bytes type, and basically the file pointer will be placed at the end of that in bytes. Okay, all right, so let's practice reading from a binary files using this problem. Okay, all right, so I copied down the problem into my PyCharm. Okay, so let's do a quick understand. Okay, let's read the problem. Given any file, read in binary mode and print content in the file a given amount of byte at a time. Okay, so basically, so we'll have to print the content of the file. Okay, given amount of time. Okay, use your function to read and print the content of the file. This file. Okay, Hamlet and C++.png. Okay, so this is a text file. This is an image file. Okay, all right. So let's write the input. Okay, so the input is given any file. So a file. Okay, file. Okay, and then for a given amount of time. Okay, given amount of bytes at a time. Sorry. Okay, content in the file a given amount of bytes at a time. Okay, all right. So let's say let's say that's a chunk. That's a chunk of the file, right? Chunk. Okay. All right. So there's a restriction as well. Your function. Yeah. So basically, you have to pick this given amount of chunk. Okay. All right. So let's write the output. Okay. Output. All right. Oops. Right. Output. We need to print the content, right? So print the content of the file. Okay. So that's the output. All right. So match is basically any reading, right? File read. Questions. Okay. All right. So let's write the plan. Okay. So basically what we need to do is basically we need to read this file. Okay. Um, given amount of bytes. Okay. And then print it. Okay. So print it to the output. Okay. So that's what we have to do. Okay. So basically need to read the file in given bytes, number of bytes, right? And print. Okay. All right. So first step of the plan, input. Okay. So we have a file and chunk. So I need to input them. Okay. And then number 2. Okay. So we need to open the file with open. Okay. Oh, well, this is the algorithm. So open the file for reading in binary mode. Okay. So 3 now basically, okay, read, right? All right. So we need to basically read uh, chunks of data, right? So, but we need to basically go all the way to the end from the excuse me, in the file, right? We have to we start from the beginning and we go all the way to the end. So that means this is, we don't know how many lines or how long it is. So we have to use a while loop over here. Okay. So and then basically we need to yeah, so use a while loop. So while, all right, so let's initialize data that we're gonna read. Okay. So okay, read let's say like part equals, okay, um, okay, part basically read a chunk into, let's say, part. Okay. So while this part is now at the end, when the once we are done with reading, when the file pointer is at the end, this part is going to be empty. Okay. So while part is not empty, okay, we are going to basically read more. Okay. So 3.1, okay, print that part, right? Okay. This part is in bytes actually. Okay. So we are reading in bytes. And then 3.2, we have to continue reading, right? Otherwise, it's going to be an infinite loop. Okay. So read another chunk. Okay. Okay. And every time we read a chunk, the file pointer is going to be at the end of that chunk, right? So so we continue on until we go to the end of the end of the file. Okay. All right. So that's it. So this is our algorithm. So let's convert this to code. Okay. So we have the file and the chunk inputted. So we're gonna open a file and it for RB. Okay. Reading binary file as our object for reading, file object for reading. All right. So now we need to first read this part. Okay. So part equals, okay, ro dot read. Okay. And how much, what is the chunk amount? Okay. So in bytes actually. Okay. Okay. Chunk. And then we are going to print it. So before, I think we need to print because we already opened. Okay, we have to. Okay, so it's not while loop yet. Okay. All right. So now we use a while loop, right? While part. So part is going to be empty, right? At the end of the file. Okay, so that's when this is empty, this is going to be false. That's when the while loop basically ends. Okay. So now we're going to print part. Okay, it's, you have to basically print it before you evaluate this expression. Okay, then we're going to print, sorry, read it again. Okay, otherwise you will not print the first part we read before the while loop. Okay, and that's it. Okay, so let's check this out on these two files. Okay, I already have it. All right. Okay, I'm comment those. So this will be a text file. You will see that. So I'm going to read 8 bytes at a time. Okay, and this will be image file. So you'll see these are in hexadecimal format. These are in literal format. Okay, so run it. Okay, so got it. So that is the this is the outcome from the PNG file read. And when we go all the way to the top, and these are the parts of the Hamlet text file. Right, so let me just open the Hamlet file just to see it. Excuse me, right here. All right, so this is the content. And if you go to the top, right here, see the protagonist. Okay, all right, so that's the content. Okay, all right, so let's go back to our lesson. Okay, so the next one is basically write into binary files. Okay, all right, so okay, write binary files. So again, we write in bytes format. Okay, so in here we need to basically now whatever the data we have, we need to convert into bytes format. So that's where usually the trick is. Okay, so we have to open the file with WB flag, writing in binary mode. Okay, so this one. Okay, and then we use the write method and we pass our data into write method. Okay, all right, and then uh, data has to be in bytes format. Okay, and write returns like in the way we saw in in text files. It returns number of bytes written. In text file format, it returns number of characters written. In here, number of bytes written is returned. Okay. So always writing will happen at the end of the file. Okay. All right. So this is the problem. So let's go to PyCharm and solve this one too. Okay. All right. So just get rid of this and about this. All right. So scroll up. It's right here. Write a Python function to write a given number of random integers between a given range, both inclusive, to binary file in a given bit size. Okay. So the default bit size is has to be 8. Okay, 1 byte. All right. Use your function to write 32-bit 100 random integers between 10 and 20, both inclusive, to file named this. Okay. And then we have to read this file again and count how many numbers of value 12 in the file. Okay. So let's first do the understand. Okay. Input. Okay. So inputs, there's a number of inputs. Okay. Given number of random integers. Okay. So rand numbers. Okay. Given range. So we have a start and end, both inclusive. Okay. Given bit size. So size and eight is the default. Okay. And the file name also given. Name. Okay. All right. So output. Okay. So we need to write 100 rand ints to the file. Okay. All right. All right. So this is restrictions are there as well. Basically, we have to make the default to 8 bits. Okay. Default size is 8 bits. Okay. All right. All right. So matches we can like text, write text files, the CSV file one. Okay. All right. So let's write our plan. So input number 1, input all this. Okay. You can copy it down. Okay. All right. And number 2. Okay. So what do we have to do over here? So basically, let's talk about that a little bit. We need to create random integer numbers, and then we need to basically write them, right? So let's just, in our understanding, let's make a note on that. Okay. Create random integers and write them to file. Okay. All right. So okay. So all right. So basically, how many? So in this case, in the example, we have to write it 100 times. So this many times, right? Okay. All right. So now we have to basically run a for loop, right? And then calculate these numbers. But before that, we need to open the file, right? Open the file for writing. Okay. And then 3, 4. Okay. For 1 to 4 for, let's say, 4 numbers between 1 and random numbers. Okay. And then now we are inside the for loop 3.1. We need to create a random number now. Okay. Create a random number and write it into the file. Okay. So create a random number. Okay. Now let's make it in 2 steps. 3.2. Write it into the file. Okay. All right, that would be it. Okay. So now let's convert this into code. Okay. All right. So I have the this one. We just change this to, this should be fine. Random numbers. Just run numbers. Okay. All right. So file name, start, end, and the default parameter, default value is 8. So this is the bit size. Okay. So write the docstring. Okay. Write random numbers into file. Okay. File, say fname. Okay. All right. So you can write, okay, between start and then random numbers. This between start and end into file fname. Okay. All right. So you have to open the file with open. Okay. Fname, the file name. All right. As we need to open it in read mode. Sorry, by write mode. So wd. Okay. All right. As, let's say, write file object. Okay. And then we need to loop over. Okay. For numbers in random numbers range. So it's had to be a range. Okay. Numbers. Now we need to generate a random number, right? So how do we create a random number? So basically, we have in this random module, we have a function to generate random integers. Okay. So basically, I'm going to write it over here. So we're gonna write this thing, right? So let's first create a random number. Random dot, this is the one, rand int. Okay. So it takes 2 parameters. First is inclusive, the last is exclusive. So basically start and n plus 1. Okay. All right. Now okay, so this is what yeah. So now this is the number that we random integer number. So we need to now convert this to byte format. So dot, okay, 2 bytes. And what is the size, right? The bit size. Okay. And the endianness is little. Okay. All right. And then this is the, now this whole thing is the byte type object that we need to write. So basically wf4 dot write this. Okay. The whole thing. Okay. Now, since my problem asks to count, what I'm going to do is I'm going to create 10 and 20. Okay. Random numbers between 10 and 20. Okay. So what I'm going to do is basically I'm going to uh, count these numbers as well, the particular number that I want to count. So I'm going to change my function a little bit. I'm going to add one more parameter. Okay. So count what, like something like that. Okay. So let's say count number. Okay. So I pass the thing that I want to count, and this function will return that. Okay. So count number. Okay. All right. So what I'm going to do is basically the count is um, initialize the count to 0. Okay. And basically if this number, okay, so I'm going to basically take this out and create outside. Okay. Our number equals this whole thing up to here. Okay. So this is just to verify. Okay. All right. So, and this one, and then basically this whole thing is this. Okay. And then what I'm going to do is if our number equals count number, and I'm going to increment the count. I'm basically counting. Okay. So count plus equal 1. Okay. All right. And then after that, I'm going to write that number into my file. Okay. So this way I can basically count a particular number that I can basically count how many I created, and then how many I wrote into the file. So that's the whole sole reason. Okay. All right. So okay. So now, okay, and then that's it. Basically, we are done. So I can now return this count. Okay. So as this file wouldn't have any return value. Return count. Okay. All right. So I am going to print this file function call over here. Print. Right. So one thing is I need to actually add the count also. So what do we have to count in our problem statement? 12. Okay. Value 12. So I'm going to count 12. So pass 12 over here. Okay. You make sure the order is correct. Number, if name, start, if name, start, end, count, bit size. Okay. So the bit size is going to be 32. Okay. And start is 10, 20. We're going to have 100 times. Okay. So here going to be 100. And the file name is fname is this one. So we're going to create this file. Okay. All right. So let's run this one. And basically, I'm going to get a count. Okay. All right. And after that, okay, I am going to see. Yeah, that's fine. Okay. Yeah. So let's run it. Okay. Okay. So it's generated 12 times number 12. Okay, because it's 10 to 20 and we are running it 100 times. So there's a good chance that we're going to repeat. All right. So that in these binary files, I have 8 32-bit 12s. Okay. I have 8 32-bit 12s in this file. So let me just open that file that we just created, random. Okay. So it's random. Oh, where is it? Run numbers. Okay. You will see that it's really gibberish. Okay. But that's fine. It's the binary format. It's not text format. Okay. All right. Now let's go back to problem um, description. It says further, read this file again and count how many numbers of 12 there. So now I have the verification, right? It has to be 8. Now what I'm going to do is I'm going to reopen this file in read mode and count whether it's 12 or not. Okay. So that part I'm going to do it in the main program. Okay. So right here, now we are done writing our file. So we have the file, otherwise we'll overwrite. Now I'm going to open this file for reading with open. Okay. And this file. Okay. And this time it's for RB reading. Okay. As R F4. Okay. All right. Now, okay, so we have to compare, right? So now we have to read how many 32-bit at a time, right? And then we need to compare that whatever that read number with 12. Okay. So before I go in loop over the file, what I'm going to do is I'm going to create 12. Okay. 12 equals this 12. Okay. And then binary byte format 12, sorry. I need to convert this to, right, byte format, because you know the whatever we read from that file is going to be bytes. So I convert this to bytes to come before I compare, not to bytes, and it's going to be 4, right? So it's 32 bits. That means 4. Okay, and then the Indian is, we wrote in little endian, so it has to be little. Okay, and now, okay, so I converted. Now I can compare. Okay, so what I'm going to do is I'm going to use a while loop in this case right now. Okay, so while, so before that I need to initialize that variable. So let's say part equals, okay, rf4 dot read. How many bytes we read? 4 bytes. Okay, 32 bits, 4 bytes. Okay, then I can start while loop, while part. Okay, now I need to, now I already read 4 bytes. Now I need to compare it with this, and so that I need to write if. Okay, so part equals this one. Okay, so I need a counter here to 0, and they're same. Well, increment the count plus equals 1. All right, now I have to continue reading, otherwise it will be infinite loop. So part and reading, and that's it. Okay, so and then at the end you're gonna print count. Okay, all right, so let me quickly go again. Okay, so we created the file. Okay, and we basically wrote 32-bit integer numbers between 10 and 20 into a binary file, 100 of them. Okay, and we found that 8 of them are 32-bit integer 12. Okay, so and we're going to verify that. We're going to read the file now and then verify it is same. Okay, Let's see that this is true. Okay. So for that, we created this 12 variable. Okay. Let me just verify. Yeah, it's 12. Okay. So, and then created the byte format 12. So I convert it to bytes. It's in 2 bytes. And it's 4 bytes. Okay. That's the size. Little Indian. All right. And then I read the file. First, first chunk, first 4 bytes. And count is now 0, and I go into the while loop and I check first. Otherwise, if this read one is 12, then I'm going to miss it, right? So before that, I need to check, and then I continue reading until the end of the file. Okay, so at the end part will be nothing. That means Boolean false, at which point we're going to come out of the loop. Okay, all right, so run it again. Okay. All right, so let's see the count. Let's see. I didn't print anything. All right, so let's see. Okay, so we didn't run it. Okay, so okay, that's good. Okay, so we have the file. Oh, I made a mistake over here. That's why. Okay, all right, that's part of the review process. Let's run it again. Okay, so I'm expecting 8 over here. Okay. Yep, I got 8. All right. So that's to verify. Okay, I wrote previously 8 32-bit 12s, and I counted back and I confirmed it. So you have a similar question to this, very similar question to this in your programming assignment. Okay, if you cannot do it, just run it again and again. Try to make sense of this code, and if you still can't, just ask me help and I'll walk you over it. Okay. All right, guys. That is it's a really broad topic, writing and reading and writing binary files, but we covered the basics, so you have a start now. Okay. All right, so this is our last lesson on files.